So again, trying to figure out a function. And again, we're working on that last assignment here in 11C, polynomial description and table to standard. Now, we have to put it in standard form, which is why I'm only having you guys do this once, because putting in standard form usually takes a little bit longer than just setting up the factors, okay? Now, the things we need to know the x-intercepts and all the x-intercepts there are, and at least one other point. Okay, so first let's start with the x-intercepts and figure out what those are. Okay, so we know that x-intercepts have 0 as in the point, but which part is 0? Is it the x or the y that's 0 with an x-intercept? Which part is 0? Because I see a bunch of zeros in that table, but which side do I pay attention to? Do I look for the 0 on the right or on the left? What do you guys think?
0 to the left, right?
Okay, so like this one right here. So is that the x-intercept right there?
Yeah.
Okay, so remember, if it's on the x-axis, let's say it's at 2 on the x-axis, that means the x value is 2, right? But if it's right in the middle of the graph, for instance, let's see, let's go to like the last assignment right here. This one, where you had to just look at the graph, right? So think about this point right here at 4. On the x-axis, it's at 4, so that means the x value is 4, and that's an x-intercept. But it's in the middle of the y-axis right here, and for y, that's 0. So what you're looking for is the right side to have a 0. Okay, if I'm looking at the table. Okay, so let's go back to the last one. All right, so my x-intercepts, I can see one here at -4, -3, -1, and 1, 0. Okay, so there's 4 x-intercepts. Okay, so I'm gonna write all those down here on my whiteboard. And then I'll switch over the screens here. So we're gonna go. What do you think would be the easiest one to plug in out of the rest? Yeah, why is that? Why would -12 be easier to plug in than the rest? Yeah, because it's got 0 in it. Once you plug in 0, it cancels out a lot of things, right? So it makes it easier to work with. Okay, so I'm gonna write that down. And what is that point, by the way? There's something special about that point. What is it? Notice that has 0, right? So if 0 is on the left, what kind of point is that? Okay. Okay, so let's flip on over. Okay, we got a 4 x-intercepts. So first, let's set up our equation. Y equals a. Remember, start with a, your stretch factor. For -4, I put x what? Okay. Rodriguez, Giselle, what would I put for -3? 3. Plus or minus? Good. Jose, what would I put for -1? What's that? Okay, so x what? Plus 1. And Hamza, the last one, for +1, what would I put here? Because -1, I put x plus 1, so this one I would put what? -1, -1, okay? All right, so we got 4 different factors. Now we have to take this and plug it into the equation. Okay, so now I'm gonna plug in the -12 over here. And I'll plug in, so 0 goes in for x for all of these. Okay, so now I just got to basically take away 0 because 0 plus those numbers is just the numbers themselves. So now I'm multiplying 4 times 3 times 1. Again, this is why I like to use the numbers that have 0 because now I just have to multiply that and now I have to add up everything. Okay, so now we got 4 times 3, 12, times 1 is 12 again, times -1 is -12. So now it's -12a here. Last step to find a, divide by -12. And a equals 1. Well, that makes things a little easier. Okay, so now my stretch factor is 1. So really, I don't even need to put anything because it's just 1. So now it's going to be just this. I could write that 1 there if I want, but it really doesn't change anything. Now here's the challenge because it's asking for standard form. Okay, so standard form means that I have to multiply these out. Okay, and again, this is why I'm only asking you to do this one time. So to multiply these out, I have to do it one set at a time. So I'm going to first multiply these two, and then I'm going to multiply these two. So I'm going to set up 2 boxes here. Now the first one, x, 4, 3. So x squared, 3x, 4x, and then 12. That's the first one. Okay, and so now that becomes x squared. And I add those two like terms, plus 7x plus 12. Now I got to do the second one, x minus 1 plus 1. Now I'm just multiplying these two. So x squared, 1x minus 1, -1. Okay, so now these two, 1 minus 1, well, those just cancel each other out. So now it's just x squared minus 1. Okay, so I still have to multiply it out until I got no parentheses. So I got one more step here. Okay, now in order to multiply 3 numbers, I can't do a 2 by 2 box. I've basically got to set my box up so that it's 3 by 2. So now on this side, I'm going to set up my box where I've got x squared here, minus 1, x squared, and then the 7x and the 12 on the top. Okay, so this will be my last step of multiplying now. So now x squared, x to the 4th, -1x squared, -x squared, and then x squared times 7x cubed, 7x times -1, -7x, okay, and then x squared times 12, it's going to be 12x squared, and then -1 times 12 is -12. Okay, so now here's the thing. You got to only add up the like terms. Only add up the like terms. So let's start with the biggest one first. The biggest one, what would I write here first? Okay, x4. So what's next? X cubed. Is there another x cubed anywhere? No, that's it. It's just the only one. Okay, so, and if I have a lot of boxes, what I like to do is kind of cross them out as I use them. That way I don't forget anything. Okay, so now 7x cubed. There's no other x cubed. Okay, so x squared, do I have to combine anything or is there only one? Okay, so you have -x squared and 12x squared. Okay, so 12 and -1 will combine and be 11. So I'm done with those. And then we see how the pattern's forming, 4, 3, 2, and then there should be an x, right? So then -7x and -12, that's it. That's all we have left. All right. So you guys in class, this is what we're going to work on first. I'm going to have you guys get started with this first thing. Okay. All right. So let's type that in. x to the fourth, and then 7x to the third. Now, on all the other times that we're doing this, all I ask you to do is leave it in factored form. So really, this is the only one where I'm asking you to do the full deal, okay? And I actually accidentally wrote x squared on my board here. It's only negative 12. Okay, so let's check it. Make sure I didn't make any mistakes. And it looks good. Okay, you can see they kind of did the same steps in making the 2x2 box. And by the way, as you guys go through these, just as a reminder, they will show you examples. Okay, so if you need to see an example to kind of matches up with your problem, just keep clicking example, show example, in case you get stuck. Also, don't forget that there's help videos too on every Deltamath assignment too. So kind of an extra video to help you kind of work through those, okay? All right, last thing I want to do is just talk about the packet. And let's see. So the first page, like I told you guys yesterday, the first page of today's assignment, only write these in factored form. And factored form, for instance, for that problem we just did, would be to basically stop right here. That's factored form. So once you get to that point where you have all the factors, you just stop there, okay? And even the Deltamath assignment before the one we just looked over, you leave it, you can do a factored form, okay? Again, the one we just did, that last one is the only one where I'm going to ask you to actually go into standard form and go all the way, okay? So that on the first page, do all of these in factored form, okay? There's 4 of them. Okay, so this one, of course, you have to find the X-intercepts first. They're not given to you. Now, do you guys remember when it bounces off the graph like that, what kind of root do we have? Or what will be in our equation? Right, it'll be squared, or we call that a double root. So when I write it out, how do I write it out? Right, with squared, or what could I do? Well, that's -2. Let's write it down first. And then there's the other one is 2. But this one basically means I could put the square or write it twice. Okay, but it means the same thing. So I can write it twice, or it means the same thing, or put the little square, okay? Now, I also am gonna need that stretch factor, right? So for each of these, I'll have an x and x, okay? And what point am I going to plug in? Because these are my X-intercepts, but what point from this graph could I plug in? Remember, we used 0, -12 in the last one. What do you think we could use here?
16.
Yeah, we used the 16, the y-intercept. So if it has a y-intercept, use it. So the y-intercept here at 0, 16, that's when I'm going to plug in, just like I did with the 0, -12 here. I plug that in. Okay. Okay, then you guys will figure out, okay, remember if it's negative, put positive, switch the signs. Okay, same thing here. Now notice what's special about this one. They're both double roots. Both double roots. So in this one, because I have double roots on both of them, I can put squared twice like this, or if you want, again, this is a matter of preference, whatever you guys want, however you guys want to do it. If you want to do just squared for each one, or write it twice for each one. Okay, I'll let you guys decide that. Okay, just again, if it bounces off the x-axis, write the double root. And then what point will you use, or what is the y-intercept that we're given here? It's right there at -3. So here we'll plug in -3, 0, -3. Okay. So here you can see it tells you it bounces off at the x-axis. So right there, that's a double root. So you'll know for that one, I got to repeat it or put the square on that one. Okay, there's the point they're going to give you. Now notice this one is not a y-intercept this time. They give you an x value that's bigger than 0 or is not 0, right? So that just means you're going to have to add, but it's still the same steps. You're going to plug that in. Okay, and then on this one, here's your 3 intercepts, and then there's your point you're going to plug in, -1 and 60. Okay, on the back. Okay, now this one, I'll talk about this one in a second. This one is just like the other day, where you got to look at the equation and determine what is the degree. What are coefficients? Because it says list and label coefficients. What part of the equation is a coefficient?
Oh, the small numbers.
The small numbers, like up there?
Yeah.
It's not the small numbers. It's the bigger numbers. It's the bases.
Oh, yeah.
So for instance, for the first one, guys, the coefficient is 6, -3, 5. What's it here? 1 and 8. Those are all the coefficients. It's the number in front of the variable. Okay, and what would be the degree here? 4, the biggest exponent. Okay, so for all of these, that's what you're doing, is labeling what are all the coefficients. And you just write them out. 6, -3, include the sign. Okay, just write them all out for each one. Okay, this one up here is the solution. Is this a solution to the equation? How can you be sure? Well, if you have an answer to an equation, any equation, what can you do to check? Without solving. With any equation you solve, if you get an answer, what can you do with that answer to figure out if it's right or not? Like if I solve 2x plus 3 equals 8 and -3, let's just say that's my equation. And I tell you, okay, guys, the answer is 2/3. All right, let's not go 2/3. Let's say answer's 3. It's not 3, but how could you check to be sure? Plug it in. So that's what you're doing. Okay, so for this one, plug it in. You're going to have to plug in that into the equation. Okay, so plug it in. Which means, basically, I'm plugging in I to the first one, x squared, and then 10 times 5 plus 2y. And I want to make sure that it equals 29. Now, if you guys remember, we were multiplying imaginary numbers the other day. Okay, so this is the same thing as 5 plus 2y times 5 plus 2y. So you're going to have to multiply with the box and figure out if it ends up equaling 20. Okay, so I'll let you guys finish the rest of that. Now, if I got an answer like this, 5 plus 2y, usually there's a second answer. Take a guess. What do you guys think the second answer would be? If this is 5 plus 2y, what would be the second one? Think about when you do the quadratic formula. You always end up with 2 answers, right? So what do you think the second one is for this one? No, without even actually solving it. If that's the first solution, because think about the quadratic formula itself. It's 5 plus and minus b squared minus 4ac, right? So like after you simplify this, you have to do one answer that's plus and one answer that's minus. So what do you think the second answer would be if that's the first one? Yeah, it's basically just minus. Okay, because a lot of times you're going to get a complex root. Okay. So this one says, where does this parabola intersect the x-axis? I want you to look at Desmos and graph it. Just look at Desmos and use that to kind of help you answer that question. So look at Desmos. Basically, just graph that in Desmos. You guys heard me at home. Graph that in Desmos and see what you get. See if you can use that to explain where does this cross the x-axis. Because if it has a solution, then you would think it would cross, but just remember these are complex numbers. So it may or may not cross the x-axis, okay? The last ones here, these are some review. Okay, this one is 2 times x minus 1 squared. What do you think you got to do with this first before you multiply anything? Okay, you could divide 2, all right? What are you going to have to do with x minus 1 squared? Right, so if I do it twice, then what method am I have to use to simplify? Right, so you could divide 2 here on the first step, but that x minus 1 squared, we're going to have to set up the box, okay? And then simplify that and then work out the rest of the steps. Now, if you guys remember the last couple of days, we were talking about logs and exponentials. That's an exponential. So in order to solve it, we got to go back the other way. Okay, so as an example, I'll give you guys an example that's not this one. Let's say I have 3 to the x minus 2 equals 7. Well, here I would add 2. Actually, let's not do that because that's too easy. Let's do 8. Okay, so I add 2. I get 3 to the x equals 10. But I can't solve it because it's a variable in the exponent. So I want to change it into log form. So it'd be log, what would be the base? No, so remember it looks like this, b to the e equals a. That's what this form is. The 3 is the base. So when I put it in log form, base goes here, a goes here, and e goes here. So what would I put here? 3, what goes there? 10, and equals what? X. Now what you're going to do is plug that into a calculator. Okay, but again, just remember that's not the same problem. That's just an example. Okay, so we'll review. All right, I'm going to stop there. There are some inequalities here, which you guys can go back and look at the notes from Ms. Menard's YouTube channel. And let's see, what section was that? Just because I don't want to take all the time here. So if I go to her channel, that's an inequality. So, and those are 1 variable inequalities. So that would be section 3.4. Okay, so 3.4 in your notes would be a good place to look for examples like that. Okay. All right, you guys at home, that's it. I'll post a recording later and I'll see you guys next week. Remember the quiz is posted and we'll Zoom again next Tuesday. Have a good weekend.